again. And I'm sure some of you finished this problem after that brief interruption. Sorry about that. Are there any questions on how I got to where we are right now? Nope. All right. I'm now going to cancel.
You missed an X when you recopied the problem.
Son of a gun. I was
In that
testing.
middle one.
I was testing to see who would catch that. Thank you, Nina. I appreciate that. Now, without breaking up any happily married binomials, I can cancel. Ooh, I can cancel. Ooh, I can cancel. So what do I have? An x plus 1 minus 2x times x minus 1 equals 2 times x minus 1. Huh. X plus 1 minus 2x squared plus 2x. I had to distribute the negative 2x equals 2x minus 2. Now I'm going to clean up that left side a little bit. I have negative 2x squared plus 3x plus 1 equals 2x minus 2. Wow, this problem's a little bit of, has a little length to it. It's a little bit of work. Negative 2x. I'm going to subtract 2x from both sides. I'm going to add 2 from both sides. Now I have it equal to 0. And as we know, we don't really care for that negative. I'm going to multiply everything by negative 1. 2x squared minus x minus 3 equals 0. Did somebody factor this already? Because I know while my machine was on the blink, somebody kept working. That has to be 2x and x. Minus 3 plus 1. Final answer? Anybody?
Well, x can't equal negative 1, so it has to equal the other one.
Right. Here's x equals 3 halves. Here's x equals negative 1. But up above we had said no. Final answer is just 3 halves. Cause we'll have fun, fun, fun. So daddy takes a T-bird. Questions? Just a potpourri of problems. All right, I want to set this next one up. We're not going to go and solve it, but just get it started for you to work on, keeping an eye on our time. This first term is 2 over x plus 3. Got that, right? It's a binomial. I can put it in parentheses. I can't touch that. This second one is, oh, it's not something nice and simple. So I may have to factor, well, I do have to factor it. What do you think it factors into? Take a wild guess what one of the terms might be.
X plus 3.
Yeah, and it is. One of them is, in fact, x plus 3. And if one's x plus 3, the other one has to be
X minus 1.
x minus 1. Perfect. Now I'm back to a problem I just did a minute ago. I'd have to take both sides and multiply it by that common denominator of x plus 3 and x minus 1. So it's really similar to the last one we did. All right, the next part, starting to work with absolute values. And in my world, when I would teach this in high school, I would call this the distance from 0 bars. What numbers have a distance from 0 of 4? Well, it's two answers, 4 and -4. X equals 4, X equals -4. Okay, and all of you understand this much. Okay, what numbers have an absolute value that's equal to +4? It can never be negative, right? I can never say the absolute value of X equals -3, because this always has to be a positive. So no soup for you. That can't exist. Always has to equal a positive. So whatever is inside of here is going to equal 4. Whatever is inside of here is going to equal -4. So I'm going to start to set some of these up. Good. I have the absolute value equal to 5. So what's inside of here is going to equal 5. What's inside of here is going to equal -5. So I'm going to end up with two answers. If I take a look at number 6, this does not look like number 5. Number 5, we had the absolute values alone. Well, I can do that. I can write this as 2 times x minus 4 equals 6. I subtracted 1 from both sides. And I can divide by 2 equals 4. That means x minus 4 is going to equal +4, or what's inside is going to equal -4. This one's easy. What's x equal?
-4.
Here, I do this one
Oh,
first.
wait, 4. Because
Add 4 to both sides.
0.
Well, that's this one. When I add 4 over here, I get 0. When I add 4 to both sides here, I get 8. Good. And if I plugged it back in, 8 minus 4, I can do that in my head. That's 4. The distance from 0 is 4 times 2 is 8 plus 1 is, the heck? Where did we mess up? We messed up right here. Come on, man. Well, is there an advantage to checking your answers? Yeah. If you want to make sure they're exactly right. Now, if I put 7 in, 7 minus 4 is 3, 2 times 3 is 6 plus 1. I like that. And if I put in, add 4 to both sides, if I put in 1, that's -3, whose distance from 0 is +3, times 2 is 6 plus 1 is 7. So 7 and 1 would be the answers. Glad I decided to check that. Number 7. We already said, nope, can't do it. Nope, never can do it. No solution. The distance can never equal -3. So negatives are no good. Now 0 is good. X plus 2 can equal +0, which is just 0. X plus 2 could equal -0, which is just 0. So this guy simply becomes X equals -2. And if I plug it back in, the absolute value of 0 is in fact 0. Lots of problems. All right, let's see what we have going here. Uh-oh. The absolute value of that is equivalent to the inside equals the inside, or the inside equals the negative of the inside. What that's saying is something along the lines of the absolute value of 6 equals the absolute value of 6, or the absolute value of 6 equals the absolute value of -6. All right, so I'm going to come up with two possible equations here. The first one is what's inside equals what's inside. Okay, U is equal to W, or what's inside equals negative what's inside of the second one. Do-do-do-do. Did you get an answer for the left side?
X equals 3.
X equals 3. 9 minus 1 is 8, and 8. I'll buy that. Right side?
X equals -3/2.
Negative X minus 5. So if I add that, I get 4X. If I add that, I get, -4. Did you distribute your negative sign? Make it minus X minus 5. If I bring this over, it's 4. If I bring this over, it's negative. I get -1. Still so quiet. Okay, the next thing we're going to take a look at, we don't have much time left, so hang in there a little bit longer, is we're going to work with radicals. And the radical is the ever popular square root. Okay, it's a square root. So in order to work with radicals, I want to get them alone on one side, if possible. Okay, get them alone. Raised to a power that'll clear it. So this is the square root. The power that I would raise the square root to is something like that. So the square root of 41 squared would equal 41. I don't know if you can see that. There it is. Solve the remaining equation. So there's some verbiage on how to do this. And we're going to follow these steps. Get it alone, square both sides to eliminate the square root. Work with the rest of the equation. So these look nice and easy and quiet and simple, but they're actually a little more work than that. Taking a look at number 10, the first thing I said was get the radical alone. So get it alone. X minus 1, I'm going to say equals X minus 3. I'm going to square both sides. What thou do to one side of an equation, thou must do to another. This is a single term. It's going to give me X minus 1. This is a binomial, so when I square it, it's like multiplying by itself. First, outer plus inner, and then the last. Zero equals X squared. I'm going to subtract an X. I'm going to add a 1. Hopefully you're good with your factoring. Should have had a lot of factoring practice coming into this class. Some of you don't remember it from quite a while ago. This was the trial and error method. X equals 5. X equals 2. Well, we might want to be really careful when we do this. If I plug in 5, 5 minus 1 is 4. The square root of that is 2, plus 3 does equal the 5. I'm happy. If I plug in 2, square root of 2 minus 1 is 1. Square root of 1 is 1, plus 3. I'm checking 2. Square root of 2 minus 1 plus 3, does that equal 2? Because the square root gives me a positive, both of my answers aren't going to work. This is going to become 1 plus 3, and that's not equal to 2. So that answer will not fly. Only the X equals 5. So, oh boy, we still have a bunch of problems to do for 1.6, but I think we're going to try to get this last one in. Well, there's nothing I can do. So I'm going to square both sides. The left side, the square, that becomes 1 minus 2x. This is a binomial. It's 2 terms. So it's going to be 2 plus the square root of 1 minus x times 2 plus the square root of 1 minus x. Ooh, I like the left side. That's not so bad. 2 times 2 is 4. If I do the outer, I get 2 times the square root of 1 minus x. If I do what's called the inner, I get 2 times the square root of 1 minus x. And when I do the last, the square root of blah times the square root of blah is just blah. All right, so I'm going to have 1 minus 2x equals 4 and 1 is 5 minus x plus 2 bananas and 2 bananas is 4 bananas. Oh, this is good. Instead of having 2 radicals, I only have 1. So now I need to get that 1 alone, sort of like I talked about over here, and I'm going to square both sides again. So I'm going to send 5 over. That's -4 when I subtract 5 from both sides. I'm going to add x. When I add x to this, I get -x equals 4 square root of 1 minus x. Divide by 4, -1 minus x over 4 equals the square root of 1 minus x. This is brutal. I had to square it twice. Well, here's the second squaring, right? Because when I square here, this is going to get rid of my radical. And my right side is going to be 1 minus x. My left side isn't so pretty because I have to multiply this by itself. And cha-cha-cha-cha-cha-cha-cha-cha. Conceptually, what I wanted you to get out of this was squaring both sides. And then I got rid of something. Then I had to square both sides again. So when I had 2 radicals, I had to square it twice. When I had 1 radical, I got it alone and squared the side. So this guy will keep going. For lack of time, we're going to stop there. If you want to figure it out before our next class. But that's going to get us up through a good chunk of 1.6, which means on Monday, no, what's today? Thursday. On Tuesday, we're going to pick up here at the end of the middle of 1.6, and then try to get into 1.7. So are there any questions? It's a very quiet 8 o'clock class. Kind of expected that, and that's okay. Okay, hearing none, I'm going to stop the recording.